So we're going to do the same thing down here for these two. So let's zoom in so we can just see A. And again, first start with our table of inputs and outputs. This time I'm going to go long way so that I keep the space. And again, I always pick the same values. So I'm going to go ahead and pick, let's pick same values here, -2, 0, and 2. Again, 3 values normally is enough to get a good pattern. Just make sure you're taking a negative value and a positive value. So those are my inputs. So now I'm going to go ahead and again, input means take them and input them for X. This one is a little bit more challenging just in the work that we have to do. So I'm going to be very careful here. My first step, I'm just going to plug in. So I get -3, and then I'm going to input my -2. And then I can see that this says plus y is equal to 8. So you may want to remember solving equations here. So orders of operation, think through that first. I can complete my multiplication here. -3 times -2 is 6. And then if you remember, how do you solve your one-step equation? Or just think in your head, 6 plus what gives me 8? If we do that one-step equation, we would subtract 6 from both sides. So then we get 2. So when I input -2, I get +2. I'm going to erase here just so that I can save space and it's not too much. Now I'm going to go ahead and input 0. So if I input 0 here, I like picking 0, 1, because it's good to see what happens on the y-axis. But when you input a 0, it's always really easy to do that math because this is always going to cancel out, right? Multiplying by 0 goes away. So then I really just end up with y is equal to 8. And now I'm going to go ahead and input a +2. And I'm going to do that math again. -3 times 2 gives me -6. So now I'm just thinking, well, what can I add to -6 to get 8? But again, this is your one-step equation. So I'm going to go ahead. What's the opposite of -6? We can add 6 to both sides. And then we end up with y is equal to 14. So now I'm going to go ahead and I'm going to erase this math here just so that I can put my graph below. Think about your scale. So my x-axis, my numbers are pretty low, but notice that on my y-axis, I have to make it all the way up to 8 or to 14. So what I'm going to do here is I'm actually going to count by 5s. Normally, I don't pick a number that big, but I can see that my values here, they're each going to come in kind of a different section here. So that's going to be okay. So then I have 1, 2, 3, and then 1, 2, 3. So now if I sketch that graph, I have -2 to 2 coming in about here. I have 0 to 8, and then 2 to 14. And so then if I draw that graph, even though I'm estimating, I get a good enough sense of that pattern to see that if I drop my vertical line here, only hits it once. So then we would say yes. And then we're going to go ahead and do this one over here. So this one is going to be a little bit different. So let's think about it. Start it with our same first method. So let's think about what our table is going to show. Okay, so I'm going to go with my same process. I'm going to say, well, let's pick -2, let's pick 0, and let's pick +2. But now let's notice here that what happens whenever we actually input these in. So I have 4x is equal to 8. Step 1, I'm going to input a -2. Okay, so then if I input a -2, no matter what I get over here, my value is going to be -8, or my value is going to be 8. So I put in a -2 and I got a y value of 8. Okay. Now, and again, this doesn't even really make sense here. So we have a lot of question marks going on. Now let's try to input a 0. So 4 times 0 equals to 8. 0 equals to 8. That doesn't make sense. But my right side is still telling me that I'm equal to 8. Okay, let's try the next one. 4 times 2 is equal to 8. And then I get 8 is equal to 8. Okay, well, that one makes sense. My y value is still equal to 8. This isn't right.